This is page 2, or the second example for part 1 of chapter 2.1, functions and their graphs. This will be example 1b combined with the vertical line test. So if the page, example 1a was not enough for you, then this is good for you to watch. So again, I'm looking at page 67 in your textbook, and this is the input-output table that they are showing you. So in the input column, they have -3, -2, 1, and 4. In the output, I guess it's not a column, it's actually an oval. They have -1, which is paired with the input value of -3. They have 1, and -2 is being paired with 1, and so is 1 being paired with 1. And then they have 4 being paired with -3. So this is how it would look in an input-output table. Your inputs are your X, your outputs are your Y. And so you have -3, -1. Then you'd have -2, 1, 1, 1, and 4, -3. So this is more typically what you see in algebra, but when they ask you about whether something is a function or not, or talk about relations, then often they will put them in these ovals. So your ordered pairs, as you can see a little bit better here, -3, -1, -2, 1, and then 1, 1, and then 4, -3. So the domain definition is the set of all, and this is at the top of your page. It's highlighted. It says domain. The set of all input values is the domain. So the domain definition is the set of all input values. Inputs are X values. And then the domain, it's actually easier. You can see them over here, -3, -2, 1, and 4, but you can also see them here, -3, -2, 1, and 4. So -3, -2, 1, and 4. You could also pull them off your X coordinates here. The range definition is really similar to the domain definition in that it is the set of all, instead of input though, it's going to be output values. And outputs are Y values. So the range values, you can either pull them off of your Y coordinates, the Y coordinates here, or the Y coordinates here. So there's 3 places you could get them. I'll pull them off here. -1, 1. Now you don't have to write 1 twice because it would be 1, 1. That's not necessary. And then -3. Now we're going to go ahead and graph the relation. Remember, relations, anytime you pair an X and a Y coordinate together, that's going to be a relation. Whether or not it's a function is whether it passes the vertical line test, that's one way to determine it, or whether for every input value, every X value, there's exactly 1 output value. So that's what we're going to look at right now. The vertical line test typically is much simpler to understand and to apply, so I encourage you to think about that. Okay, -3, -1, and -2, 1, and 1, 1, and 4, -3. Now, we're going to go ahead and do our vertical line test. I'll use a different color here. So for the first point, -3, -1, -3, -1 is the only point on that vertical line. So far it is passing the vertical line test. On the second vertical line, the only point on that is -2, 1. So far this is still a function because it's passing the vertical line test. We go to 1, 1. There's only 1 point on that vertical line. So again, it's passing the vertical line test. And then the last one, the vertical line goes through 4, -3, and 4, -3 is the only point on that vertical line. So these ordered pairs, -3, -1, -2, 1, 1, 1, 4, -3, These are a function. So I'm going to come down here a little bit further. We're going to write some other things to help you with this. But the relation is, let's go back to blue, is a function. So again, is a function because there's a couple reasons. It passes the vertical line test. And what it means when it passes the vertical line test is that for every input, there's exactly one output. So for -3, there's only -1. The input of -2, there's only 1. The input of 1, there's only 1. The input of 4, there's only -3. So for every input, there is exactly one output. Sometimes students get a little bit confused about when the output values are the same. So let me finish writing this. Or for every input, there's exactly one output. Okay, so we're going to come back up here and we're going to look at the table because this sometimes stresses students out and they think that it's not a function. So when you look here, you'll see that there are two y's, or these two inputs go to one output. It's okay to have two different inputs go to one output. So you can have matching for the same outputs. Those are your y's. That's okay. Because those form a horizontal line. You can see that there's a horizontal line right there. Horizontal lines are fine. So you can have matching outputs. They can be on the same line horizontally. So you can have matching outputs, y values, and it is still a function. So that's really important. What you can't have are matching x values. So like if you look at your x values, -3, -2, 1, and 4, they are not matching. They're all different. Whereas if you looked at the A example, again, this is our 1B. Let me write that down. Page 67, example 1B. So page 67. If you look at 1A, you can see you have -2, but you have the input value of 1 twice, 1 -3 and 1 1. So it's okay to have matching output values, but it is not okay to have matching input values. When you have two x's that are the same, it's not going to be a function. So in this case, this one again, just a reminder, this particular one, this set of ordered pairs, this relation is a function because it passes the vertical line test, 1 point per vertical line. And what that means is, or you could write this instead, for every input there is exactly one output. Hopefully you found this helpful.